Hello everyone, welcome to this video on errors and exception handling in Python. So errors are common in any programming language. Let it be a program for finding average of 10 numbers or say developing large applications like ERP, banking software, developing a website. But we need to take utmost care by developing critical applications like military applications, medical applications, financial softwares. Otherwise it will lead to huge loss of say crores of rupees or say loss of human lives. So in short, let it be a small application or a critical application, the errors needs to be identified, corrected and handled in a proper way. We have already learned about the three types of errors, that is syntax error, logical error and exceptions. But we have gone through the syntax errors and logical errors in detail in one of the video in past. So it is given on our YouTube channel under a playlist Python for beginners, and the video is over here, type of errors in Python and error handling in Python. So if you want to know in detail about the different types of the syntax error, we have discussed 6 types of syntax error in this particular video. We have also discussed about the logical errors in detail in this particular video. So you may refer to this particular video if you want to know more about syntax errors and logical errors. In this video, we'll learn what is an exception, what is a runtime error, and how to handle runtime errors using Python's exception handling mechanism. So let us start with a small program to read an integer number from keyboard and let us print that number. So over here I have one statement to read a number from keyboard, and here is a simple statement to print a by message. Now let us print the value of y that we are reading from the keyboard. So print, and here we can have value. So this is a printf statement to print the value of y. And now let us run this program and we can see that so it is asking for a number from keyboard. Let us enter 6. So here we are getting the output that value of y is 6, and here it is printing the by message. And fine, now let us run this program again. Now let us enter say for example p. Now we can see that there is an error, and the error is value error, invalid literal for int with base 10. So now suppose again if I run this and if I enter the correct input, say for example 12, then it is running correctly. From this it is concluded that if we give the correct input which is expected by this particular program, that is integer number, then this program is running correctly. Here also there is no syntax error and hence it is running correctly. Fine. But if we give some wrong input, let me run it again and say for example k. So when we give the unexpected input to this program, it is not able to handle, and hence the program has crashed. And this is an example of a runtime error because this error has occurred while executing a program. So such runtime errors are referred to as exceptions. Now the question is how to handle such errors, because the program is correct syntax wise as well as logic wise, but the error occurs only when we give unexpected input to this particular program. So Python has a mechanism to handle such runtime errors. So there is a try and except statement within Python to handle such errors. So what we need to do is similar to if and else statement block, we need to define the try and except statements. Now the very first thing is to identify these two categories of statements. One is normal statements, second is critical statements. The normal statements are the statements, for example this print by message. So this is a normal statement. But if we look at this statement is for accepting integer input only. Over here we can see that the error is due to this statement, that is this input statement. This statement can accept integer input, but if we enter character input, then it will not be able to accept the input and hence it gives error. So we have to identify such statements which are likely to generate errors. This kind of statements are referred to as a critical statement. So we have to keep the critical statement over here. Means over here let us keep that statement within the try statement. So here is my try block similar to the if block. Fine. And now let us define the except block similar to the else part, right? Except, exception, and similar to the else block in except block, we can write such statement like oops, that was not a valid number, try again. And finally we have to print the value of y, and this is a simple statement. Now let me once again explain. Similar to the if block and the else block, we have a try and except block. In try block we have to keep the critical statements the statements which are likely to generate errors. In except block, we can handle the exception, but for simplicity, we are printing just a message that, oops, that was not a valid number, try again. And then finally, we are printing the value of y that we are reading from keyboard, and then a by statement. Now let us run this program. Let us see what is output. If we enter correct input, it is giving answer, that is value of y is 10 and by, and then program process finished. So over here, we can see that this message is not displayed. Means when there is no error, it will read this value from keyboard, stores it in y, and then print that value, and then this statement is printed. Now let us run this program again. Now let us enter some unexpected input and say we have entered letter y, and now we can see that error message is not displayed, and message displayed is, oops, that was not a valid number again. When we enter this y from keyboard, this statement is executed, and the Python error identifies that this is not the right input for this particular statement, and hence the Python interpreter raises an exception, and it will directly jump to this exception block. Means this statement is not executed, means this statement is skipped from execution. So directly it jumps over here, and here it prints this message, and that is after accepting this, it is directly printing this message, and finally it is executing the last statement of this program. So now let me explain what is this exception. So this exception is nothing but a base class of all the different types of exceptions in Python. So when we are not aware of the type of error, we can directly specify this class over here. Now we can see that here actually there is an error, and that is why this message is displayed. Now suppose I want to know what is an exact error over here. What is the error message? So what we can do, we can create an object of this exception as say error. So accept exception as error, and here we can print that message over here, comma error. And now let us run this program again, and let us enter some invalid input, and here we can see that, oops, that was not a valid number, try again, and here it is displaying the actual error which has occurred. So invalid literal for int with base 10. So already we know that it is because of this statement accept the integer input only, and hence this is the error. So we need to run this program again, and we need to enter the correct input. We'll see how we can handle this exception in little bit better way little later on, but in short, this is what the meaning of exception, that is a runtime error, and this is how we can handle such runtime errors using try and except block, and this is how we can print the actual error message using an object of the class exception. In Python, there are a number of different built-in exception types. For example, arithmetic error. So this exception is raised when an error occurs in numerical calculation. Then there is an attribute error raised when attribute reference or assignment fails. Then there is a index error raised when index of a sequence does not exist. So this is nothing but index out of range. So index out of error is nothing but when we try to access a list index which is out of bound. Same way over here again, these are few more errors. Say for example, memory error, name error, overflow error. So all these are the different built-in exception types. So the best practice to handle exception is to specify this specific built-in error name over here. Now let me tell you how we can know that. Right now let me just comment this program statements, and let me take these two statements outside over here, and let us uncomment these two statements. And now let us run it, and let me enter a wrong input, and here we can see that the name of the error is value error. So this is the actual name of exception that occurs while executing this particular statement. So what can we do over here? Instead of this particular exception, we can write value error like this. Now let us remove these two statements, and other code will remain as it is. So we are generating an object of value error, and then we are printing that particular message. Now let us run it, and if we enter the correct number, it will run as usual without any exception. But if we enter a wrong invalid input, fine, then it is executing the statements within this except block, and it is printing this particular error message, that invalid literal for int with base 10. Let us add some more functionality within this particular program. Say I have a variable x is equal to 10, and I want to divide this x with the value of y that we are entering from keyboard. And let us modify here answer of x by y is this one. And now let us run this program and let us enter a value, say for example 5. Then we can see that answer of x by y is 2 because x is equal to 10 and y is equal to 5. So 10 by 5 is 2. Now let us run this program again and say for example we want to enter 20 and by mistake I entered 0. Right? By mistake I entered 0. So now just see the error, 0 division error. So here we are handling one type of built-in error, but while writing such program we need to identify all the different types of errors that are likely to occur in our program. So the important point to note over here is with one try block we can have multiple except block also. We can have multiple except block over here. So we are handling value error over here and here we will handle the 0 division error. And here let us handle the error by printing such message that hey, you cannot divide a number by 0, and let us print this error message, actual error message over here. And now let us run this program. So if we enter say for example 20, then answer is 0.5 because 10 divided by 20 is 0.5. But again let us run it and say for example by mistake I entered 0. Then now we can see that now there is no error, but the error is handled in a right way. Fine. So now after executing this particular statement is executed in this particular except block. Hey, you cannot divide a number by 0. That message is displayed over here, and then the actual error message, that is division by 0. So this is how we can have multiple except blocks with one try block. Now it may happen that here we may have few more statement and some other type of error may occur. Then we can add one more except block over here also. Means as many blocks are required, we can add that many except block over here. But sometimes it happens that we don't know all different possible runtime errors, and hence we should have one generalized except statement, except, and that generalized should be the exception as error. And here we can have some message like print. So over here in this program we have one try block and 3 except blocks, and 2 except blocks are specific to specific error and one is a generalized exception block. Over here what we are doing, we are just printing a message, but we can have some code over here to handle exception in a better way. Now over here what happens, if my input is correct, the program is executing correctly and the program is finished correctly, we come out from the execution of the program. But if there is a runtime error or if there is an exception, then it is just displaying this error and we are coming out from the execution. But in real-time application, the scenario should be little bit better than this one. As far as we are entering the wrong input, it should give a chance to user to enter the input again. So over here what we can do, so until the user is not entering the correct input, it should ask the user to enter the correct input, and when correct input is given, the program will be executed correctly. So how can we achieve this particular thing? So what we can do, it should repeatedly ask until the user is not entering the correct input, and hence we need a loop. And best thing is we can have a while loop, and over here it should go on and on until a user is not entering the correct input. And let us have these all statements within this particular while block itself. So over here what we have done, we have kept the all the try and except block within the while statement, and here this is always true. But when if a user enters correct input, it will not raise any exception. Also this statement x divided by y will also not generate any exception, and hence objective of finding the value of x by y is achieved, and hence the program execution should be completed. But if there is an exception, then it will go within this particular except block and it will again come over here, right, and it will again ask user for the correct input. Now let us run and see how it is working. So over here, say for example I enter a wrong input like this, we can see that the message is displayed, that is oops, means this particular value error exception is raised, and again it is asking for the number. number, please enter the number, means this statement is executed, means again it is within the loop. Again, let me enter some zero. Say for example, by mistake I entered 0. So again we can see that, hey, you cannot divide a number by 0, and right now this particular second exception has occurred. So again it is asking for the input. Now let me again enter some input, and we can see that again it is. So it is within the loop until the user is not entering the correct input. It is within the loop. Now say for example, I am entering value 2 from keyboard, and now we can see that answer of x by y is 5 because value of x is 10. 10 by 2 is 5, and then it is printing this message, and finally program execution is completed. So this is how we can use try and except statement for handling different kinds of exceptions or runtime errors. Now here is a task for you. Write a program to evaluate following expression: answer is equal to x plus y plus z divided by, in parenthesis, x minus y. Read values of x, y and z from keyboard and print its answer, and handle these two kinds of exceptions: value error and zero division error that we have demonstrated in this particular video. After writing this program, you can paste this program in comment section. I will review your program and I will let you know the appropriate feedback. Let me know if you want any help. If you have any query related to Python, data science, machine learning or artificial intelligence, you can write comment on our YouTube channel. I will definitely answer your queries. So let me briefly summarize this particular video. Here we have learned what is an exception. So exception is nothing but runtime errors, and Python provides a try and except statement to handle this kind of runtime errors. So similar to if and else statement, we have the critical statements within the try block. The except blocks are used to handle the exceptions. When exception occurs or runtime errors occurs, the execution directly jumps to the except block, and this except block is not executed if there is no runtime error. Except block is only executed when runtime error or exception. And here the third important point that we have discussed is we can have multiple except blocks with one try block, and also we have seen that there are different types of exceptions, and the best practice is to use the name of the specific exception while handling the exception, and also we should have a generalized except block for handling all those exceptions which we are not aware of. In next video, we'll see how to handle exception using try and except statement with the finally as well as else statements. Like this video, share with your friends, and if you have not subscribed our channel, please subscribe to our channel and don't forget to hit the bell icon so that you can get updates related to the new videos and also news and events related to data science, machine learning and artificial intelligence. That's all. Thanks for watching. Have a great time.